Let's roll. Here we go. First proof up. I won't even say a word about what we're leading into today. But look at that proof statement. That looks a little intimidating, huh? All right, the colons are just another way of writing a ratio. So if you don't like the way this looks in the proof statement, you can certainly rewrite it. FC over dB equals AC over PB, if you don't like the way that looks. I am asking you to prove corresponding sides are in the same ratio. But I'm hoping as you picked up through this unit, you can't do that unless we know what about our triangles. They're similar. So that's our first step. Before the sides are in the same ratio, the triangles need to be similar. Now you take a quick peek at this diagram. Whoa, buddy. Well, I got a lot of triangles working here, don't I? I got to figure out which ones I need to prove similar. So how can I use the proof statement to help me find which triangles to prove similar? Well, what's one side I need to prove in the proof statement? FC. All right, so here's FC in the same ratio with DB. I think I know the two triangles already without even having to go to the other pair, right? Everyone see the, or you, go ahead, AC. Oh, I think I see one of the triangles here, ACF. And PB, looks like I'm going to have to prove ACF similar to DPB. All right, can you help me do that now? What's the only way we're going to do it in a statements reasons proof, proving triangles similar? Angle, angle. So I need somebody to find me a pair of angles. The triangle's isosceles with AB being congruent to AC. Maybe that'll help you. You also have an altitude and a pair of perpendicular lines. Maybe that'll help you. So first, let me open it up to somebody first. Two, look at that. 1 out of 100, 2 comes up. Any angles, any angles that you can identify in either triangles. Okay, angle B. And I'd probably not say angle C. Yep. So everyone see those two angles at the bottom. One's in the yellow one for me, and the other one's in the pink one. So angle B, yes, indeed, is congruent to angle. Let's see if I go BAC. What's that letter there? I crossed it off. F. True statement. How's Connor know that? What theorem, midterm review is he applying? 2 again. Look at that. What are those odds? Let me tell you, 1 out of 100 times, it's 1 out of, what's 100 times 100? 4 zeros? 1,000? 10,000? That's a 1 out of 10,000 chance that just happened right there, everybody. Only in what type of figure? In a triangle, yep. In a triangle, congruent angles are across from congruent sides. Only in math class do you witness something that could only occur 1 out of 10,000 times. Any other pairs of angles up here? I think my luck's going to run out, though. Any other pairs of angles? Yeah, my luck ran out. Big time. Big time. Big time. 26. Okay, they are right angles, but they're going to be right angles for different reasons. So just like the proof we did yesterday, I need 2 steps to say that they're right angles because they're going to be right angles for different reasons. So let me start with the first one you gave me, which is AFC. Angle AFC is a right angle. All right, why would AFC be a right angle? What in the givens told us that it was a right angle? Angle AFC. 10. Hi, how are you? You want me to repeat the question? Okay, let's keep the focus here. AFC, why is it a right angle? Okay, definition of an altitude. Altitudes form right angles. And then we also have, Connor told us that angle BDP was a right angle. And that's for a different reason. 5. There you go. And then, yes, got to tell me what now? Both of those right angles are congruent to each other. Do I have both pairs of, 2 pairs of angles? Okay. Now, just be careful here because this was in the proof statement yesterday. What you got to make sure you write. Yeah, if I could talk today, if you could write correct triangles in the same order. Who's got it for me? 9, correct similarity statement here. I have no idea. Is that good? CFA, yep. Everyone, self-respect, self-respect. Why am I saying that? Similar sign, not the congruent sign. Angle, angle. Let's take it one step further now. Now the triangles are similar. Corresponding sides are in the same ratio. Bless you. Bless you. Whew, going 3-bagger? No? Thought you were going 3 in a row. So it looks like we have a new reason now, don't we? Well, why are the corresponding sides in the ratio? Because we proved the triangles similar. So similar triangles imply corresponding sides in the same ratio. But who wants to write all that, right? So we have, I don't know, cousin, brother, sister. I don't know if CPCTC, if the triangles are congruent, corresponding sides are congruent. We have corresponding sides in similar triangles are proportional. Again, yes, if you want to use this, it's got to be in the correct order. I have no sympathy for you if you put CTPSS XYZ. All right? CSSTP. Corresponding sides in similar triangles are proportional. All good? And there is one other step we got to do tomorrow after this. Like, what can you do to this after? But we'll talk tomorrow. Let's roll. All right, great review. Here's our boy, the parallelogram. Prove the 2 triangles similar to each other. Everyone see the 2 triangles? Because there's 3 triangles in the diagram. Make sure you know which 2 we're proving similar here first in part A. CED and BEF. Give me a pair of angles you see there. Any pairs of angles? It's going to get old quick. 2. Yep. Okay, we got the vertical angles. All right, no big deal. Usually see those right away. CED congruent to FEB. Where are the other pair going to come from? 26. Okay, well, first, yep, I'm glad you brought that up. You can't say these alternate interior angles are congruent right away. You got to tell me what about the lines before they become congruent. They're parallel. So, yep, first thing we could say is yes, DC is parallel to AB because this is a parallelogram, and that implies parallel, opposite sides parallel. A lot of review here. Then, yes, what Connor just said, we could extend AB out to AF. So now DC is now parallel to AF, and we called that extensions of parallel lines are parallel. Now he chose, what did you choose, Connor? F? Okay, he chose angle F and CDE. You could also do angle C and angle CEB. That's fine as well for the alternate interior. Just pick a pair. So angle F congruent to angle EDC. Parallel lines imply alternate interior angles congruent. And then now you could say the triangles are similar, and step 7, part B looks like to be the corresponding sides of those two triangles, so there's in proportion. It's really hard to make these tough until tomorrow anyway. CSSTP. We all good? I'm kind of over the proofs already. Let's go hardcore algebra. What do you say? It's not going anywhere. Some of you guys that don't like it is not going anywhere, this algebra. All right, let's roll. AB is parallel to CD. I needed to know that. The parallel lines make the triangles similar by angle, reflexive and corresponding angles. Once the triangles are similar, the sides are in the same ratio. Now, quick question. I showed you guys a side splitter theorem yesterday. Can I apply that to this diagram? No, it's called the side, calm it down back there. All right, yeah, I know. All right, you're making fun of me from yesterday. I get it. All right. You really scared me with that, with the 1, the hood up, and 2, the hardcore Bethlehem cross country hoodie. That's got your fellow thugs. Yep. When you go out in the streets of Del Mar. Heads up, coming through. Little Milk in his cross country. Yep. Everyone, spread it out. Spread it out. I kid because I like you, Teddy. All right. And why can't I do side splitter, Teddy? Side splitter, yes. Not if I'm given the lengths of the parallel lines, I can't do it. I need to move 4 and x plus 3 out here. Okay? All right, so give me a side. Here we go. Name 2 sides that match up. We'll do the easier ones, which are 4 and x plus 3 match up with. There's a pair of corresponding sides. All right, now you got to watch your mouth. What does the x minus 1 go to correspond with? Not 2. It's x minus 1 plus 2. Don't write that here. Simplify it before you write it in your proportion. It'll be x plus 1. Okay, let's cross multiply. I got 4x plus 4. I'll give you guys a minute or two to go ahead and double distribute x plus 3 and x minus 1 to see what you get. Just want to make sure your algebra game is good to go. Take your time, but when you're ready, let me know. 14, when you simplified anything, let me know. Yep, equals. Guys, all right, let's go, go ahead. What happened to the two middle terms? Okay, ready? X squared. X times -1. -1x. Then you got to distribute the 3. You forgot about the two middle terms. What do I get here? 3x. And then here? Minus. Okay, combine those two middle ones here for me. -x plus 3x. All right, so we get a little bit more than x squared minus 3. Got to do the two middles. Guys, what's the highest exponent showing in this equation? 2. Going to have to maybe factor here. All right, so let's bring 4x minus 4 over. X squared. I'll ask somebody this one as well. It's going to take me a while now. 10. I'm moving 4x and 4 over. What do I end up with? Minus what? Yep. Okay, everyone ready? Now, some of you are already starting to figure this out. I need two numbers that multiply to what? -7 and add to, let me know when you get there. We're not getting there, right? Because you can't factor this. And let me give you a little tip from now on. Go back to the directions. The directions already should have told you that you wouldn't have been able to factor. Why? Simplest radical form. And what's the only formula that gives me simplest radical form? Quadratic. So if you see those directions, don't even bother wasting your time factoring. You're not going to be able to. So yes, we are going to need the quadratic formula, which I, again, will give you on Monday's quiz. All right, here we go. This takes all of my steam out. I'm being lazy. I just go over and hit 30. 17. What's my B value? So when I plug it in, Teddy, to right here, to quadratic formula, it'll become 2. Plus or minus. You guys know how I feel about this. I wouldn't plug it in yourself. I'd store it in. Store it in your calculator. Calculator's never going to let you down. Let's figure out what number's underneath the radical. Store in A, B, and C value. And figure out what B squared minus 4AC is. Let me know what that number is under the discriminant is underneath the radical. 27 when you're ready. $32. Also, you have done it 100% incorrect if you get a negative underneath the radical. That's a no-no. All right, if you're doing that, you better be using your store key, big time. All right, because you're trying to be a hero and doing it yourself. All right, use your store key. On the bottom, what was our A value? 1, so 2 times 1, I get a 2 on the bottom. Keep it going. This is not simplified. We did a lot of practice with this. 32. 32. 16 and 2. Got to be the biggest perfect square for those of you who said 4. So keep going. 2 plus or minus square root of 16. 4 radical 2. All over 2. Still not simplified. Remember, the 2 in the denominator goes with the left and the right side of the plus or minus. What do I get when I reduce those two right there? 1. So I have 1 plus or minus. Let's go to the other side. The 2 is still there. It applies to the right side. Which ones can I reduce? 4 and the 2, so 1 plus or minus 2 radical 2. We still got 5 minutes left. This could get real awkward. Do you have a diagram? I can't have a negative answer. Everyone go to your calculator right now if you have one in front of you. Somebody do 1 minus 2 radical 2. What do you get out? I don't care what you get out. It's negative, isn't it? Okay, well, I got a problem because if I plug that number into here, what type of side length am I going to get? Negative. So even while I know you guys are so used to that when you factor, but when you use quadratic formula with the diagram, you got to watch out for that as well. So there's only one acceptable answer, and that's 1 plus 2 radical 2. All right, so please watch out for that. All right, you're on your own now.